Okay then, 7.6 is another lesson where we're dealing with triangles, we're solving things in triangles, we're finding information, and we have to use two triangles to do it. Now, I'm just drawing a quick little diagram. Please don't draw this, but let's say that's a right triangle, and let's say, I don't know, let's say that's a right triangle. That's helpful. In yesterday's lesson, we were given enough information in one of the triangles in order to solve for a shared piece of information. And then once we got that shared piece of information, we would have enough information in the next triangle to solve for whatever we really wanted to find out. Does that make sense? So we used one triangle to get shared information. That gave us enough information in the other triangle to solve for the thing that we actually needed to get. In this lesson, we're not going to have that situation. Okay? In this lesson, just quick general thing going on here. In this lesson, we're going to want something that's shared. And we're going to be given partial information over here and partial information in this triangle. And we're going to have to say that the partial information in this triangle is equal to the partial information in that triangle because they both represent this shared piece. So we're going to come up with an expression for that shared piece from one triangle and an expression for that shared piece from another triangle, and then set those expressions equal to each other and then solve. Okay, so it's a little bit more complicated. It comes up in your assignment. It comes up on your test. We're going to do two examples that do basically the same thing. Slightly different, but you'll see. And so you need to learn how to do this. You need to be able to do this. You need to be able to see when this comes up. Okay, right now I'm telling you that it's coming up. But when you get it on an assignment or a test, you just need to be able to know what strategy to use. So here we go. 7.6, example 1, pilots. Many pilots flying from small airports follow visual flight rules. Under these rules, an aircraft can take off only if the visibility is 5 kilometers or greater. So from the ground or from the tower, they need to be able to see 5 kilometers or more. Sorry, I'm just taking a break to draw my diagram here. Mine's not perfect, but it gives you an idea. And the cloud height has to be 300 meters or higher. Airport managers determine the cloud height visually during the day. To determine it at night, they have a spotlight that shines on the clouds. The angle that the beam makes with the ground is 70 degrees. So I'm going to start adding things to the diagram. Here we have our light. Okay, that's our spotlight shining up into the clouds. And the angle that it makes with the ground is 70 degrees. An observer is located 300 meters from the light. I'm going to call that O for now. That's our observer. And that tells us that this whole distance from here to here is 300 meters. What else do we know?
He's staying like at 60.
An observer located at on the ground 300 meters from the light measures the angle of elevation to the point where the light shines on the clouds. That angle of elevation is 60 degrees. 60 degrees. And the light, suppose the angle of elevation is 60 degrees and the light and the observer are on opposite sides of the point. Find the cloud height to the nearest meter. All right, so I'm actually going to rename all of my letters. I don't know if you're using pen or pencil, but I'm going to name them A, sorry, start over, A, B, C, and D. A, B, C, and D. All right. So we want to find the cloud height. So this is what we're interested in, right? H right here, the length of this line segment will give us the height of the clouds. If it's greater than 300, he can fly. If it's not, can't fly, okay? Now, this is tricky. We're given this length from A to C, but we only have tools that allow us to work in right-angled triangles. Okay, so I'm going to let H represent the cloud height. That's going to help me create two right-angled triangles. But we also want to name these lengths. Okay, let's call the base of ABD, let's call it X. And in triangle BCD, let's call that base Y. That just gives us names to talk about things better, okay? All right, there are other pieces of information that I can determine about this triangle just right now from looking at it with a quick mental math. What are those things? What do I also know about this triangle that's not already in the diagram?
The top angle.
Yeah, I know these top angles, these little angles, okay? This top one is going to be 90 minus 60. It's 30. This top one is going to be 90 minus 70.
Well, we don't know that's actually
20.
90. It doesn't tell us that.
Yeah, it does.
It has a right angle.
It's right
On one
angle.
side.
Supplementary angles, 90. Okay, you do know that.
Oh.
Good. All right, let's carry on from here. What do we know that involves x plus y? Well, we know x plus y is 300. So we're just going to kind of write things that we know at first. And we're going to take a little note. Since x plus y equals 300, we can use the right triangles. We can use the right triangles to express h in terms of x and, let's use x or y. Mr. V, that's crazy language. What does it mean to express h in terms of x or y? It means that when we're done this, don't write this, but it means that when we're done, we're going to get h equals something. And on this side, we're going to have either an x or a y. It's going to be something, something, something x, or x something, something, or x times this. Okay, that means that we're expressing h. We have h by itself. We're expressing it in terms of x, or in terms of y. If you do something to x, you'll get h. That's basically what it's saying. It's the same as in any line, like a linear equation, y equals 7x plus 4. You're expressing y in terms of x. Okay, that's just new language that you need to pick up. All right, so we've got two triangles. Let's look at triangle ADB first, and we're going to separate this into two columns, kind of, in triangle ADB. What can we say about h? Well, let's think about the tools that we have. We've got our trig ratios, and h is right here. It's in both triangles. And if I look from the 60-degree angle, it's the opposite in both, okay? If I look from the 20-degree angle or the 30-degree angle, it's the adjacent side in both. If I look from, what I want to do here is I want to look from this top angle in both cases. And remember, I'm trying to express h in terms of y over here. And over here, which we're doing first, I want to express h in terms of x. So what I want is a trig ratio that involves h and x. Which one is that going to be? Which trig ratio?
Tan.
Tan. Okay, so in this triangle over here, I know that the tan of 30 degrees is equal to x over h. Good? Well, let's look at our other triangle. In triangle, doesn't matter really what we call it, BDC. Maybe we have to use the right three letters, but we don't need to worry too much about what order we're using them in. So in this triangle, what trig ratio, looking from angle D, is going to give me an expression that uses h and y?
Tan also.
Tan of
20.
20 degrees equals y over h.
Why is it y over?
Do I know what, yeah, opposite over adjacent. Do I know what y is?
No.
No.
Not yet.
Do I know what h is?
No, not yet.
So you can still see how in both of these equations I'm actually missing two pieces of information. Okay? We think that we can't solve things if we only have if we only have one out of the three pieces of information. But we do have enough to create an expression that will allow us to solve it, because at some point we're going to come back and we're going to use this information. Okay, so let's look back here, because if I'm going to plug things in here, I actually need an expression for x. Well, I can do that. How do I get an expression for x out of this from triangle ADB? What happens if I multiply both sides by h?
So you get x times h.
Mm,
X times tan.
I get x equals h times the tangent of 30 degrees. See that? Let's look across at triangle BDC. What happens? How do I get y by itself?
Multiply by h.
Multiply both sides by h, giving me h equals the tan of 20 degrees. Now I'm going to come back and use this other statement that I know. Since x plus y equals 300, I know now that here's an expression for x, h times the tangent of 30 degrees. And here's an expression for y. So add that, h times the tangent of 20 degrees. And that equals 300. What just happened? We substituted. How many variables do I have left? One. One equation, one variable. What do you know about that? You can solve it. Okay? So now I'm solving it for h. Solve for h. And that's exactly what I wanted, right? The height of the clouds. After I get that, could I then solve for x and for y?
Yes.
Yeah. Okay, it'll be easy because I'll have h, so I'll be able to use my trig ratios again to get x or y, or get one of them and then do 300 minus that is the other one. Okay, it's all going to work out. So now we're at a bit of a tricky part. We need to reach back into what we know. I have two terms here, right? This is a term, and this is a term. This part's a little bit tricky because you guys look at this and you say, oh boy, what is that? But I've told you many times, it's just a number. The tangent of 30, it's just a number. So you have some number times h plus some number times h. Any way of getting those h's just to be like one h together?
H squared? No. Divide both sides by tan something. I don't know.
Starts with an F, rhymes with
FOIL.
factorization. Yeah, we're gonna factor h out of both terms. Okay? If I pull the h out of this term, I'm left with tan 30. If I pull the h out of this term, I'm left with the tangent of 20. Huh. Now what?
Then you can.
Take the h out and
Nope.
we
No,
divide
you
both
need
sides by
Look at this, please. I'll do it in a different color. I'm going to divide both sides by this big group. Okay, this is a group, so I can deal with it as though it's one entity, and it really is, because tangent of 30 is just a number with a bunch of decimals. Tangent of 20 is just a number with a bunch of decimals. So I can just add them up and then divide by that. In order to keep it exact, I'm going to make sure that I actually just use these expressions without using the approximation that my calculator gives me. But I'm going to divide both sides by the tangent of 30 plus the tangent of 20. And I'll write what that looks like in our next step before doing it in our calculator. So now we know that h equals 300 over tangent of 30 plus the tangent of 20. Now you don't need to keep the brackets in the bottom. This division line creates an automatic group in the numerator and the denominator. I kind of like to keep them just because it reminds me that this is one single entity. And this you can plug in your calculator as long as you do it carefully. Okay, as long as you do it, well, your calculator should actually be able to do it without any brackets. But just to make sure, I would put brackets around there. You should end up with 318.7. So go ahead and try that in your calculator. Make sure you're typing it in properly.
Because I tried it without before.
Sure, go ahead and put the brackets in. I just thought maybe it would use order of operations
What should we
automatically. But
Yeah, I needed brackets.
so can this pilot fly? Can pilots take off today?
Yes.
Yep. Cloud height. They should check the visibility first, but since cloud height is 319 meters approximately, they can fly. Okay, again, what did we do? We noted what we needed to find was h. We expressed h in terms of x from one triangle and expressed h in terms of y from the other triangle. And then we used this little piece of information that they gave us, which was, by the way, in the diagram. So at first you might have looked at that 300 and been like, wow, thanks a lot, that's useless. But not useless, okay? Tells you that x plus y is 300. So always look out for that type of information too. All right, that was example 1 from 7.6. Second example makes us do pretty much the same thing again. This time they don't give us a diagram, so you need to read and give it a diagram. So actually, why don't you, in pencil, lightly, go ahead and read very carefully, and I'll read it for you as well, and try and draw a diagram of what you've read. So it says the Confederation Bridge spans the Northumberland Strait and joins New Brunswick and PEI. Great, thanks a lot for the useless information. From one point in the strait is just a river, by the way, kind of. Anyway, it's a body of water that goes between two land masses. The angle of elevation from one point in the strait, the angle of elevation to the highest point of the bridge is 27 degrees. Then when your boat keeps going 100 meters closer to the bridge, you'll look up and the angle of elevation to that same highest point is 73 degrees. And we need to determine how high the bridge is to the nearest meter. So you're in a boat, going down the river, you look up, top of the bridge is 27 degrees, angle of elevation. You keep driving in the boat, you look up again, and now it's 73 degrees. Draw a picture. All right, I'm going to start with my horizontal boat traveling here. And I'm going to pick a point directly under the bridge because I know I'm going to need some right angles here. This is supposed to be about 27 degrees to the top of the bridge. So that looks good. I'll label that 27 degrees. Then after 100 meters, let's say there, I'm going to look up and the angle of elevation is going to be 73 degrees. I know that the distance from here to here is 100 meters. And I know this is a right angle. So that's what comes directly from the word problem. Give myself some vertices to talk about, A, B, C, D. And so now I have two triangles to talk about. I want to make sure I'm talking about right angle triangles. So I have triangle ADC and I have triangle ADB. And again, there's a little bit more information that I can figure out. I'm going to have to be careful. because both triangles, so one triangle is contained inside the other triangle in this diagram. So I've got this little angle right here. All right, if your numbers don't fit, just draw lines. That's 90 minus 73, which is a 17-degree angle. That's in my little triangle. But then I need to be careful when I'm doing my next angle. It is not this angle, okay? It's all the way across to this vertical line. And that angle is 63 degrees. And just so that I don't confuse myself, I'm actually going to write that one outside the triangle as well. If I write it here, I might think that it's this angle, but it's not. It's the whole thing from right. Okay? And I am trying to find out the height of the bridge. So I'm going to label that lowercase h. And then they give us this 100-meter thing. Why do you think that's useful? What else should I maybe label? How about the base of each triangle? Okay, so I've got this base right here from C to D. Let's call that X. And then I need the base of the bigger triangle from B to D. And I'm going to call that Y. So again, I have a situation where I have both the bases of the triangle. They share a height. And I know a whole bunch of the angles within those triangles. Okay, what simple math sentence is going to be helpful to me later on? X plus 100 equals y. That's different than we had in the last example, right? In the last example, we had x plus y, the two unknown bases, equal 300. I'm going to write it a little bit different. I'm going to say that y minus x equals 100. Okay, you could write it either way. 100 plus x equals y. Subtract x from both sides. You get this one right here, okay? We're just going to keep that in mind. We're going to remember that for later. And now we're going to use both right triangles to develop two expressions for h. So again, if you can develop two expressions for h, then you can substitute, or you can set them equal to one another, and then you can solve for h. Nope, I lied to you, and I think I lied to you last one as well. We're not. Could be a way to do it. Scratch that, reverse it. Okay, we're going to develop two expressions. One for x, one for y. And those are going to be in terms of h. Okay, that's a bit better. You probably would have just understood what I was doing anyway, but we're going to look at our two triangles. We're going to start with triangle, our big triangle here, ADB. And then over here, we're going to use triangle, our little triangle, ACD or ADC. And again, we're going to develop two expressions. So in our large triangle, we have, looking from angle A, this big angle that we've been given, we have adjacent, which is what we're looking for, and we have opposite. Now opposite we called y. So I'm looking at SOHCAHTOA. So I have the tan of 63 degrees is equal to opposite over adjacent. Make sure you understand that before we move on. I'm going to do this something in my little triangle here. Same thing. We're looking from the top of the bridge here. We have a 17-degree angle. We're taking the tangent of that because the tangent ratio is opposite over adjacent, x over h. Okay, over here on my left side in triangle ADB, we're going to create an expression for y in terms of h. All I have to do is multiply both sides by h. Y equals h times the tangent of 63 degrees. On the right hand side in triangle ADC, same thing, multiply both sides by h is going to give me an expression for x in terms of h. It's h times the tan of 17 degrees. And now I get this helpful piece of information. I know that y minus x equals 100. Y minus x equals 100. I know what y is in terms of h. It's h times the tan of 63. And I know what x is in terms of h. It's h times the tan of 17. That equals 100. Following the exact same steps as last example, what do I do next? Factor out the h on the left-hand side. That will leave me with the tan of 63 minus the tan of 17. Last step.
Divide both sides by the tan of 63, 17, 17.
Yep, divide both sides by this group here. Which gives me the approximate height of the bridge. Try it in your calculator. Nice. The bridge is about 60 meters tall, 60 meters high. Your practice problems for lesson 7.6 are on page 355. Numbers 1 through 14. That probably has a mix and match of questions using tools that you've learned last lesson as well as this lesson. Enjoy.